What is an acre-foot?
One acre-foot is equal to 43,560 gallons, 164,875 liters, of water. Which is what it would take to bury an acre of land in a foot of water. The term is usually used to measure rainfall runoff, reservoir capacity, and irrigation.
What is the Bergeron-Fine-Diason mechanism?
Swedish meteorologist Tor Harald Percival Bergeron, 1891–1977, formed the theory that is accepted today about how clouds formed, including the role that ice crystals, water vapor, and temperature play. His theories were later confirmed by German meteorologist Walter Fine-Diason, 1909–1945. The process of cloud formation is therefore known as the Bergeron-Fine-Diason mechanism.
What are northers?
Also known as blue northers. These are cold winds that blow southward from the Texas plains down to the Gulf of Mexico.
Are there trees that predict the weather and tell time?
Observing the leaves of a tree may be an old-fashioned method of predicting the weather. But farmers have noted that when maple leaves curl and turn bottom up in a blowing wind, rain is sure to follow. Woodsmen claim they can tell how rough a winter is going to be by the density of lichens on a nut tree. Before the katydid awakes, a black gum tree is able to indicate the oncoming winter. Trees can also be extraordinary timekeepers. Griffonia, in tropical West Africa, has 2-inch, 5 cm, inflated pods that burst with a hearty noise, indicating that it is time for farmers of the Accra Plains to plant crops. Trichilia is a 60-foot, 18-meter, tree that flowers in February and again in August, signaling that it is time, just before the second rains arrive, for the second planting of corn. In the Fiji Islands, planting yams is cued by the flowering of the coral tree.
What should I do when a tornado approaches?
Try to get to the lowest level of the building, unless you are in a mobile home or outdoors, in which case you should seek a sturdy and safe shelter. Many mobile home parks have a centrally located tornado shelter these days. Go to the center of the room and hide under a sturdy piece of furniture. Stay away from windows, hold onto the leg of a table or something else stable. And protect your head and neck with your arms. If your home has a basement, take shelter there. If not, interior bathrooms are usually the sturdiest rooms in a home. And you can protect yourself further by climbing into the bathtub.
What is a solar flare?
Solar flares are sudden, powerful explosions on the surface of the Sun. They usually occur when large, powerful sunspots have their magnetic fields too tightly twisted and torqued by the hot, swirling plasma in the Sun. The magnetic field lines unwind and break suddenly, and the matter and energy that had been contained rushes outward from the Sun. Solar flares can be many thousands of miles long, and they can contain far more energy than all of the energy consumption of all of human history on Earth.
What are the types of snowflakes as identified in the International Classification System?
The types of snowflakes have been stellar plates, as the name indicates, are star-like flakes that are flat, distinctly hexagonal, with 6 broad arms. Sectored plates are similar to stellar plates, but also have prominent ridges pointing to each of the 6 facets in the plate. Double plates occur when 2 stellar plates are connected by a cap. Usually, one plate is much larger than the other. Split plates and stars happen when parts of 2 separate plates merge to form one plate that, if not closely inspected, looks like a single 6-armed plate. For example, a partial plate containing 2 arms could merge with one that has 4 arms left, leaving a 6-armed plate that appears like a complete single plate. Simple prisms tiny, 6-armed. Flat snowflakes that are hard to distinguish with the naked eye, but are a very common form. Stellar dendrites have tree-like arms. Dendritic means tree-like, with multiple branches extending from each of the 6 arms. Fern-like stellar dendrites are stellar dendrites with more frilly, fern-like branches. Radiating dendrites, spatial dendrites, are dendrites that have arms extending not just in 2 dimensions, but in 3. Capped columns look like columns that have 6 flat sides. Imagine 2 hexagons that are joined together. Hollow columns are similar to capped columns, except the ends of the columns are hollow or devoted. 12-sided snowflakes when 2 6-sided plates join together at a 30-degree angle. They form what appears to be a 12-armed plate or capped column.
Who contributed to early work in plate tectonics?
There were several key scientists who contributed to the study of plate tectonics as it became more favored in the late 1960s. One of the most popular scientists to discover evidence for plate tectonics was J. Tuzo Wilson. 1908 to 1993, by 1965, he described the origin of the San Andreas Fault, the large crack in the Earth's surface near San Francisco, California, as a transform fault, or strike slip, one of the major plate boundaries. In 1968, Xavier Lepichon, 1937, participated in the definition of the overall plate. tectonics model and published the first model quantitatively describing the motion of 6 main plates at the Earth's surface. In 1973, he wrote the first textbook on the subject. Other geologists have made major contributions to the development of the plate tectonics theory. William Jason Morgan published a landmark paper in 1968 explaining the many tectonic plates and their movements. He also recognized the importance of midplate volcanic hotspots that create island chains such as the Hawaiian Islands. Walter Pittman III was instrumental in interpreting the pattern of marine magnetic anomalies detected around mid-ocean ridges. An indicator of active seafloor spreading and evidence of plate tectonics. And Lynn R. Sykes used seismology to refine plate tectonics. And he noted the connection between transform faults at the mid-ocean ridges and plate motion. He also co-authored Seismology and the New Global Tectonics in 1968, which relates how existing seismic data could be explained in terms of plate tectonics.
What causes a tornado to dissipate?
Just as the formation of tornadoes is not well understood, neither are the reason for why they disappear. One theory is that when colder air begins to flow out of the storm, the mesocyclone at the center of the storm becomes surrounded by cooler air, the tornado is robbed of sufficient energy and loses power. However, this is not a hard and fast rule. And cool air outflows have been observed that actually are followed by tornado formation.
What is a chinook?
A chinook, sometimes called a snow eater because it melts snows, is a wind that is generally warm and originates from the eastern slope of the Rocky Mountains. It often moves from the southwest in a downslope manner, causing a noticeable rise in temperature that helps to warm the plains just east of the Rocky Mountains.
What is air?
Sometimes when people think of air, the gas that comes to mind is oxygen. Actually, oxygen molecules, O2, are in the minority in our atmosphere. Only 21% of Earth's atmosphere is oxygen, with the majority of it being nitrogen gas, 78%. The rest is a mixture of argon gas, 0.9%, 0.035% carbon dioxide, CO2, water vapor, and traces of helium, xenon, methane, CH4, nitrous oxide, N2O, neon, and krypton, not to be confused with kryptonite. The stuff that hurt Superman, and a scattering of dust, pollen, and other particulates.
What is a phreatic eruption?
Phreatic eruptions are steam-driven explosions that occur when groundwater or surface water is heated by magma. Lava, hot rocks, or new volcanic deposits. The intense heat of such material can cause water to boil and turn to steam, generating an explosion of steam, water, ash, blocks, and bombs.
What is the evidence supporting global warming?
More and more scientists are becoming convinced that we are seeing an increasingly swift transition toward a warmer climate on Earth. Data is constantly being collected by meteorologists, environmentalists, and other scientists working in labs and out in the field. While there is no definitive proof that will assuage all doubters, the evidence is mounting. Below are some of the reasons why the fear of global warming is gaining ground. Record-breaking temperatures. Cities around the world have been recording high temperatures in the last decade or two that have exceeded all previous records. Drought and rain pattern changes. Dry areas are becoming drier, and wet areas are becoming wetter. Floods are becoming more frequent, as rivers fill with record levels of water. For example, the American Midwest and Great Plains states have seen significant increases in flooding in recent years. Though part of this can be blamed on farming and levee activities. The Northwest is also seeing much more rain, while the Southwest and especially southeastern states have been experiencing extended droughts. More extreme weather. Some, though certainly not all, scientists feel that hurricane and tornado activity appears to be on the rise, with the United States and Southeast Asia being particularly hard hit. One of the worst years of recent memory, 2005, included the devastating Hurricane Katrina that destroyed New Orleans and other Gulf Coast cities. Climatologists noted that there had been a lull in hurricanes during the 1970s and 1980s. But since 1995 there has been a significant upswing. Between 1995 and 2005, 9 of the hurricane seasons had above normal incidence of storms. Warming oceans, coral reef bleaching. There is widespread and undisputed evidence that coral reefs around the globe are in trouble. Although coral reefs occur in tropical, warm waters, too much warming will kill coral. First, because the organisms simply don't tolerate such temperatures. And second, because warmer water is not able to maintain as much dissolved calcium, which coral need to survive. When corals die, the vivid colors the tiny animals lend reefs disappear, hence the term bleaching. Melting glaciers. The most commonly used piece of evidence for global warming has been the changes seen in glaciers, especially in the north, but also in Antarctica and on mountaintops around the world. Photographs have shown, for example, that Greenland glaciers are retreating at a rate of about 100 feet, 30 meters, per day. In Antarctica, the Larsen ice shelf, covering an area roughly the size of Rhode Island, broke off the mainland. Meanwhile, the glacier on top of Mount Kilimanjaro in Tanzania is quickly melting. And scientists speculate there will be no more snow on the mountain by 2020.
Can a lightning stroke cause you to burst into flames?
No, being hit by lightning will not make you combust, but it can leave burn marks or singe clothing.
What is acid rain?
Motor vehicles and industrial activity release tons of pollutants into the air. When mixed together, the pollutants form sulfuric and nitric acids that later fall to the ground in rain or snow. This precipitation is known as acid rain. Acid rain is responsible for damaging lakes by killing plant and animal life and for killing trees around the world. Canada has been especially hard hit by acid rain caused by industrial activities in the United States.
Who first proposed the idea of ice ages?
Several scientists over the centuries came close to proposing the idea of ice ages. Scottish naturalist James Hutton, 1726–1797, observed strangely shaped glacial boulders. Erratics, near Geneva, Switzerland. Based on this, he published his theory in 1795 that alpine glaciers were more extensive in the past. In 1824, Jens S. Mark 1763–1839, proposed that past glaciation had occurred on a much larger continental scale. But the most persuasive argument for ice ages came in 1837, when Swiss-American geologist Louis Agassiz 1807–1873, gave his now famous speech on past widespread ice age conditions. He proposed that nearly all of northern Europe and Britain had once been covered by ice. And he subsequently found evidence for his theory in New England. Others eventually uncovered additional evidence. In 1839, United States geologist Timothy Conrad 1803–1877, discovered evidence of polished rocks, striations, and erratic boulders in western New York, supporting Agassiz's theory that Ice Age glaciation was worldwide. In 1842, the first attempt to explain the Ice Ages using an astronomical connection was made by French scientist Joseph Hadamard, 1797–1862. He proposed that the Ice Ages were the result of the 22,000-year precession of the equinox, a natural movement of the Earth's axis that causes the seasons to switch over thousands of years. In other words, the current summer months would become winter months and vice versa.
What is August Nato?
Seen near thunderstorm outflows, A gustnado is a weak vortex that does not touch the clouds. Gustnados usually do little more damage than breaking some tree branches and overturning lawn furniture.
Do tornadoes strike in countries other than the United States and Canada?
Yes, but the United States keeps the best records on tornadoes. And so it is difficult to ascertain the frequency and ferocity of twisters in foreign nations. The Canadian prairie experiences significant incidents. But one could say that these are all part and parcel of the North American conditions that are ideal for tornado formation. Other countries that have significant accounts of tornado activity include Great Britain, Italy, Western France, Brazil, Argentina, Russia, Bangladesh, China, Northern India, Pakistan, Japan, South Africa, and New Zealand. England experiences a tornado about once every year and a half, and Australia probably has more tornadoes than are witnessed. Because many of them likely occur in the outback, where the population is sparse.
What causes ice ages?
No one knows why ice ages occur, but there are several theories. One possibility is that the sun's energy varies in intensity over time. Each time there is a decrease in activity, an ice age may occur as the Earth cools. Another possibility is an increase in dust in the atmosphere, either from volcanoes or a large meteorite impact. The debris from either event would reflect more of the sun's light into space. Albedo, cooling down the atmosphere and causing more snow and ice to form. This would also further increase the world's albedo, as even more sunlight would reflect off the ice and snow. However, this theory has a problem, as many of the other theories do, in that it doesn't explain what causes the ice sheets to retreat.
Where can I get an education in meteorology?
There are numerous colleges and universities throughout the United States and the world where you can earn a degree in meteorology. The American Meteorological Society publishes information on this in its curricula in the atmospheric, oceanic, hydrological, and related sciences, which can be accessed online at http://www.amatsoc.org. The U.S. military also provides training to interested recruits. Online and correspondence courses may be found, too. But these should be viewed more for informational purposes and not for a formal education. Unless the online courses are provided by a degree-conferring, accredited university.
How do I know if meteorology is for me?
Choosing a career to pursue is one of the toughest choices anyone has to make. Unlike generations past, though, most Americans do not remain in their first career choice forever. And many change careers 3 or more times over their working lives. This is one reason why meteorology is actually a good choice. Because it can be applied to a wide variety of specialties. There are some questions you can ask yourself before you decide to pursue meteorology. 1.
Which Chinese scholar first hypothesized about climate change?
In the 11th century c. Chinese writer Shen Kuo, 1031 to 1095, noticed that bamboo plants were buried in the ground near Shanbei. This region was far too northerly for bamboo to grow in Shen's time. And he therefore reasoned that the climate there had once been very different.
How big can a raindrop get?
The laws of physics restrain raindrops from getting too large before they break up into smaller droplets. Thus, about 0.25 inches, 0.635 centimeters, is the largest a drop can get and still have the surface tension of the water hold it together.
What is a whiteout?
An official definition for whiteout does not exist. It is a colloquial term that can describe any condition during snowfall that severely restricts visibility. That may mean a blizzard, or snow squall, etc. If you get some sunlight in the mix. That makes the situation even worse. It's like driving in fog with your headlights on high beam. The light gets backscattered right into your eyes and you can't see.
What is nuclear winter?
A nuclear winter is what would follow a large-scale nuclear war. Radioactive particles, dust, and smoke released into the atmosphere would create a large cloud over the planet, blocking out sunlight and reducing temperatures worldwide. Plants and animals would die due to the extremely low temperatures and reduction of sunlight. An extended nuclear winter could cause the death of millions of people from starvation, cold, and other problems.
What is the driest place on Earth?
Probably the driest place on the planet is the Atacama Desert, which is located in Chile near the Pacific coast. The average rainfall here, specifically, in the town of Arica, is about 0.02 inches, 0.05 centimeters. Meteorologists believe this never-ending drought is the result of the Humboldt Current. which blocks rain from reaching the Atacama Desert. There are some parts of the Atacama Desert that have not seen a drop of rain in centuries.
Occurring during the summer, how warm can it get in Antarctica?
Antarctica is not always an icebox perpetually below freezing. During the summer months, it can often get into the 40s and 50s Fahrenheit, 4 to 14 degrees Celsius. The warmest temperature on record thus far on the continent is 59 degrees Fahrenheit. 15 degrees Celsius, at Vanda Station on January 5, 1974.
What is plasma?
Plasma is the fourth state of matter, the other states being solid, liquid, and gas. It is formed when electrons are stripped away from atoms and a mix of free electrons and the resulting ions exist together. Plasma is found in stars, which makes it actually the most common state of matter in the universe. But plasma is also found in the solar winds that blow out from the sun and collide with the magnetosphere. Some plasma radiation makes its way into the ionosphere, too. Lightning is also a form of plasma.
What is the National Severe Storms Laboratory, NSSL?
The NSSL is NOAA's premier research laboratory. Located in Norman, Oklahoma, the NSSL is dedicated to researching and improving weather radar systems, severe weather forecasting, and the science of hydrometeorology.
What U.S. drought has been the costliest in terms of financial damages?
There have been many severe droughts in the United States over the course of history. The most famous one is the Dust Bowl of the 1930s. However, in terms of money, the costliest drought thus far has been the 1988 to 1989 drought that resulted in an estimated $40 billion hit to the U.S. economy. Over half the country's population was negatively affected.
Was the sun generating less energy at its core than expected? Was nuclear fusion theory wrong?
The problem was finally solved nearly 4 decades after it was first discovered. Neutrinos, as it turns out, can actually change their characteristics when they strike Earth's atmosphere. That meant that there were the right number of neutrinos leaving the Sun. But so many of them changed flavor upon reaching Earth that they escaped detection by the neutrino telescopes deep underground. This discovery was a major breakthrough in fundamental physics. It confirmed very important properties about neutrinos that have major implications on the basic nature of matter in the universe.
What are evaporation and transpiration?
Evaporation, as many people know, is what happens when liquid water changes to a gaseous state, escaping into the surrounding atmosphere. The rate of evaporation can be measured using an evaporimeter. Transpiration refers to the release of water vapor from plants, but can also refer to perspiration and sweat being lost from humans and animals.
What is a nuclear winter?
Scientists Richard Turco and Carl Sagan made the world cognizant of the effects of a global nuclear war in the early 1980s. And Sagan published a popular book on the subject, The Nuclear Winter, in 1983. While most people were already terrified of the nuclear arms race that had been going on between the United States and the Soviet Union since the 1950s. The idea that every major city on Earth could be obliterated by atomic and hydrogen bombs was just the beginning. Sagan and Turco showed that it wouldn't even take all of the then 50,000 nuclear warheads to kick up enough dust and debris to block out the sun's warmth. Clouds of irradiated dust would be blown into the stratosphere, where they would circle the planet for months, plunging us into an artificial winter that would destroy crops and lead to a global famine. Since the publication of The Nuclear Winter, many scientists have come to believe a similar scenario could happen if a large asteroid hit the planet. Indeed, this is one theory about how the dinosaurs may have become extinct 65 million years ago. Another possible cause of a nuclear winter would be planet-wide volcanic eruptions, which some scientists theorize led to a snowball Earth hundreds of millions of years ago. Actually, when volcanoes are involved, it would perhaps be more accurate to call these volcanic winters.
What is transportation forecasting?
Most people are probably familiar with this specialty in forecasting, which helps warn car drivers and truckers that road conditions could be hazardous. It also helps prepare local governments to clear streets and freeways, spray road salt or sand, and have law enforcement and emergency personnel ready for emergencies. On the business level, weather forecasts can warn shipping companies, for instance, not to ship perishable products in unrefrigerated or unheated trucks. Shipments by rail also need to be ready for unfavorable weather conditions. Some larger companies rely on private forecasting firms to provide them with timely advisories.
What is a meteorite?
A meteorite is a large particle from outer space that lands on Earth. They range in size from a grain of sand on up. About 30,000 meteorites have been recovered in recorded history. About 600 of them are made primarily of metal, and the rest are made primarily of rock.
How were the first high-altitude photographs of clouds taken?
During World War II, cameras were mounted aboard some of Germany's V-2 rockets to take pictures of cloud patterns. The success of these efforts inspired meteorologists to plan for weather satellites.
Is the hole in the ozone layer causing frog species extinctions?
Biologists have known for a long time that frogs are very vulnerable to changes in their environment. Frogs across the globe were being found with deformities, such as extra legs, and species were going extinct. By the mid-1990s, it was still being speculated that the cause of the mutations was the weakened ozone layer, which was allowing too much ultraviolet radiation to filter onto the planet. Today, however, most scientists believe that the culprit is fertilizers leaking into the lakes and rivers where frogs live. The fertilizers cause certain types of snail species to thrive, and these snails often host parasites. The parasites, in turn, infect frogs when they are still in their tadpole stage. Cysts form on the tadpoles, which creates the mutations that are being observed. Besides the malformations seen in frogs, there is another, even more troubling concern. Many species of frogs, some estimate about 100 species, are vulnerable or threatened with extinction, and many others have already disappeared. In this case, the culprit is global warming. Because frogs have thin skin, they are vulnerable to environmental changes. Increased temperatures have caused fungi. Some scientists specifically blame the chytrid fungus to infect frog skin. And this leads to the lethal disease Batrachochythrium dendrobatitis, BD. The good news is that it is easy to treat and cure frogs. The bad news is that even if they are treated, once released back into the wild they are likely to be reinfected. To help arrest the extinction rate, zoos around the world have been rescuing sample populations and breeding them in captivity.
What is climatology?
Climatology is the study of the world's climates and how they are changing over time.
How much water is in the world's oceans?
Earth is about 70% covered by oceans and seas. And about 97% of the world's total water is contained in the oceans. 2% of this water is in the form of ice.
Can volcanic eruptions affect the global climate?
Most volcanic eruptions do not affect the global climate. Although larger ones can cause disruptions, albeit for a relatively short period of time. Large eruptions tend to eject gases and dust high into the stratosphere. From there, prevailing winds carry the particles around the world, sometimes with interesting results. For example, in 1815, Mt Tamborat on the island of Sumbawa, near Java, Indonesia, erupted, putting out a record amount of ash that briefly changed the world's climate. Huge amounts of volcanic dust rose high into the atmosphere, reaching around the globe. That year, and for some of the following year, volcanic particles screened out some sunlight, causing the global temperatures to fall. In Europe and other parts of the northern hemisphere, winter never seemed to end, with frosts occurring throughout the summer. Hence, 1816 is known as the year with no summer. Scientists used to believe that cooling of the atmosphere could result from volcanic eruptions because of the amount of ash that was thrown up into the air. Now they know, however, that most of these fine particulates return to the Earth within about 6 months. What actually has a greater effect is the sulfur dioxide, SO2, that volcanoes produce. Sulfur dioxide reacts with water vapor, and the result is a long-lasting haze that blocks out a considerable amount of the sun's radiation.
What U.S. city is particularly noted for its problems with smog?
Los Angeles has a rough time with smog. The brown haze that often lingers over the city is a result of several factors. Of course, the urban area is filled with cars and other sources of pollutants. But the natural environment conspires to make matters worse. First of all, very little rain falls in LA, which might attract tourists and new residents but does nothing to wash away pollutants, and secondly, the city is in a basin surrounded by mountains. Ocean breezes blowing in from the west keep air pollution from escaping in that direction. But then the smog finds another barrier in the mountains that lie east, north, and south of the city. Even before Spanish and other European settlers came to the area, the Native American Chumash tribe called what is now Los Angeles the Valley of Smoke, because haze from brush fires and dust would be trapped there for long periods.
Why do the Denver Broncos have a particular advantage at Invesco Field at Mile High?
After the original Mile High Stadium was demolished in 2001, the Denver Broncos moved to Invesco Field to play football. Here, as with other teams in Denver, such as the Rockies. Players have a distinct advantage over visiting teams because their lungs are already accustomed to the higher altitude. Fortunately, the human body can quickly adapt, and if a visiting athlete is able to arrive in the Denver area a couple days before a game, he or she should be able to play on a PAR with the locals.
How many layers does the Earth's atmosphere contain?
The atmosphere, or skin of gas that surrounds the Earth, consists of 6 layers that are differentiated by temperature. 1. The troposphere is the lowest level. It averages about 7 miles, 11 kilometers, in thickness, varying from 5 miles, 8 kilometers, at the poles to 10 miles, 16 kilometers, at the equator. Most clouds and weather form in this layer. Temperature decreases with altitude in the troposphere. 2. The stratosphere ranges between 7 and 30 miles, 11 and 48 kilometers, above Earth's surface. The ozone layer, which is important because it absorbs most of the sun's harmful ultraviolet radiation, is located in this band. Temperatures rise slightly with altitude to a maximum of about 32 degrees Fahrenheit 0 degrees Celsius. 3. The mesosphere, above the stratosphere, extends from 30 to 55 miles, 48 to 85 kilometers, above the Earth. Temperatures here decrease with altitude to -130 degrees Fahrenheit -90 degrees Celsius. 4. The thermosphere, also known as the heterosphere, is between 55 to 435 miles, 85 to 700 kilometers, above Earth's surface. Temperatures in this layer range to 2696 degrees Fahrenheit 1475 degrees Celsius. 5. The ionosphere is a region of the atmosphere that overlaps the others, reaching from 40 to 250 miles, 65 to 400 kilometers. In this region, the air becomes ionized, electrified, from the sun's ultraviolet rays. It is divided into 3 subregions. 1. The D region, 40 to 55 miles 65 to 90 kilometers. 2. The E region, also called the Kennelly-Heaviside layer, at 56 to 93 miles. 90 to 150 kilometers, and 3, the F region, 93 to 248 miles 150 to 400 kilometers, which is further separated into the F1 layer and the F2 layer, also called the Appleton layer, with the dividing line being at about 150 miles, 240 kilometers, above sea level. 6. The exosphere lies above the thermosphere and includes everything above 435 miles, 700 kilometers, high. In this layer, temperature no longer has any meaning.
What is the air pressure on top of Mt. Everest?
Mountain climbers ascending the peak of Mt. Everest, 29,029 feet, 8,848 meters. Will find the air pressure to be about a third of what they are used to. That's important not so much because of the pressure itself, but because it means there is also 2/3 less oxygen to breathe. When climbers reach 26,246 feet, 8,000 meters, they are at the point above which is the death zone. Many people carry oxygen tanks with them when they reach this height. Although some consider it a particular test of their mettle to go without. High altitude sickness hypoxia causes fatigue, distorted vision, confusion, and loss of memory and appetite. Cerebral and pulmonary edema will set in if a person goes too long before returning to normal air pressure. And this can prove fatal within a couple of days. Frigid temperatures and lack of oxygen have killed dozens of people who have attempted to reach the top of the world. Overall, more than 150 climbers have died on the world's tallest mountain.
Does lightning give off X-rays and radio waves?
Almost since the invention of the radio, it has been known that lightning generates radio waves. Since this property of the bolts has long interfered with radio broadcasts. Lightning generates radio waves over a wide range of frequencies, especially in the AM broadcast band. More recently, scientists have become fascinated by lightning's ability to create X-rays. The theory that this might occur was first proposed in the 1920s by Nobel Prize-winning physicist C.T.R. Wilson, 1869 to 1959, who theorized that lightning could accelerate electrons with sufficient speed to produce X-rays. For decades scientists thought Wilson was wrong, because they believed the Earth's atmosphere was too thick and that air resistance would slow down electrons too much. However, by the 1990s scientists began to change their minds. And in 2003 experiments with controlled lightning strokes were performed by Martin Uman at the University of Florida and Joseph Dwyer at the Florida Institute of Technology that demonstrated lightning can indeed produce enough energy to overcome any atmospheric drag. Such new research is causing scientists to rethink how lightning works.
Does the Coriolis effect make the water in my toilet, sink, and bathtub swirl clockwise?
No, the Coriolis effect has very little effect on such small bodies of water. The flow down the drain is mostly a function of the shape of the container. Interestingly, if your body were completely symmetrical, and no one's is, and neither leg were longer and you were walking on perfectly flat land, then you might start veering due to the Coriolis effect.
What is the tablecloth cloud?
The Table Mountain near Cape Town, South Africa, is sometimes covered by a thin sheet of clouds when air is flowing off the top of the mountain in all directions. When this happens, the resulting cloud formation looks like a linen sheet. Hence, local people have named it the tablecloth.
How much energy does one bolt of lightning contain?
A bolt of lighting contains enough energy to light a 100-watt light bulb for 3 months. To be more technical, each stroke of lightning has about 30,000 amps and 1 million volts of power, on average. Some superbolts can have up to 300,000 amps of power.
What are some other katabatic winds called?
In addition to the Chinook, the Santa Ana winds that flow down the Sierras in Southern California, and the Taku, which is a frigid wind in Alaska, are both examples of katabatic winds.
What did Sir Isaac Newton contribute to the science of meteorology?
In terms of meteorology, Sir Isaac Newton, 1642 to 1727, is mostly a significant figure because the science of physics and his laws of motion are essential to an understanding of how weather works. Not many people know, though, that Newton also was into rainbows. He was the first to demonstrate how white light is broken up into its spectrum when it passes through a glass prism.
What is the ecliptic plane?
The ecliptic plane is the plane of Earth's orbit around the Sun. Ancient astronomers were able to trace the ecliptic as a line across the sky. Even though they did not know Earth actually orbited the Sun, they merely followed the position of the Sun compared to the position of the stars in the sky, figured out. Despite the Sun drowning out the light of the other stars, where the Sun was every day. And noticed that every 365 days or so the positions would overlap and start going over the same locations again. That line marked a loop around the celestial sphere. Astronomers marked the line using 12 zodiac constellations positioned near and through the loop.
Why is Earth's magnetic field important to life on Earth?
Earth's magnetic field extends out into space, creating a structure called a magnetosphere, which surrounds our planet. When the magnetosphere is hit by charged particles from space, such as from the solar wind or from a coronal mass ejection, it deflects these particles away from Earth's surface, significantly reducing the amount that strikes life forms down on Earth's surface. This protects us from the hazards of being hit by too many such particles.
What are coronas and anticoronas?
A corona is a glowing white ring edged with blue on the inner side and red on the outer, and seen around the moon, or less often, around the sun, usually during eclipses. It is caused by light being diffracted by water droplets in a thin cloud, such as an altostratus cloud. The smaller the droplets of water in the air, the larger the corona will appear. An anticorona, sometimes called a glory or Brockenbau, is one or more concentric rings that appear when an object, such as an airplane, casts a shadow on a thin layer of clouds. The anticorona will appear on the side opposite of where the light source, sun or moon, is.
Who first formed the theory about the greenhouse effect?
Irish physicist, mathematician, and chemist John Tyndall, 1820 to 1893, who succeeded Michael Faraday. 1791 to 1867, as the superintendent of Britain's Royal Institution. Began conducting research in radiant heat in 1859. He soon concluded that water vapor was vital for holding in warmth in the Earth's atmosphere, and that other gases, such as carbon dioxide and ozone, also played a role. He proceeded to play with a number of calculations, changing the amounts of these gases in his formulas to discover what the results would be. Tyndall concluded that increasing a gas like carbon dioxide would have significant effects on the climate that we now call global warming.
What is a Rossby wave?
Named after Swedish meteorologist Carl Gustav Rossby, 1898 to 1957. Rossby waves refer to the large air mass waves that inhabit the middle layer of our atmosphere, including the jet stream and high and low pressure systems.
What replaced the WSR-57S?
WSR-74S were added to the radar grid in 1974 and were used in conjunction with the older 57s, as they were called. It was not until 1988, however, that the next generation radar, NEXRAD, also called WSR-88D, were built using the newer Doppler technology. The first NEXRAD was deployed in Norman, Oklahoma, in 1990. There are now 160 NEXRAD radar stations throughout the United States.
What is aviation forecasting?
Aviation forecasting is a critical support service for the airline industry. Aviation forecasters warn pilots and airline management about potentially hazardous weather conditions that could lead to wind shear, wing icing, severe turbulence, strong winds, thunderstorms, or other dangers. While passengers might be frustrated by the delays in air travel that result from these warnings, aviation forecasting probably saves hundreds, even thousands, of lives every year. In addition to the worst-case scenarios that might occur if pilots were not warned of dangerous weather, aviation forecasters can also advise on wind conditions that can help save fuel by not having planes fly into head-on winds. When the cost of airline fuel rises, this has the potential of saving airlines billions of dollars.
What is the Doppler effect?
The Doppler effect refers to the way sound and light waves behave, depending on the motion of the transmitting and receiving objects. As objects move away from each other, waves become stretched out. And as objects move toward each other, waves become compressed. When it comes to sound waves, the result is that one hears a higher pitched sound if an object making noise comes closer. If that object is moving away, the result is a lower pitched sound. When it comes to light waves, compressed visible light is shifted toward the blue spectrum, while it is red shifted if objects are moving away. Astronomer Edwin Hubble, 1889 to 1953, used this information about light waves to form his theory of an expanding universe. The Doppler effect gets its name from Austrian physicist and mathematician Johann Christian Doppler. 1803 to 1853, a figure in history whose real name has caused considerable confusion. His baptismal certificate indicates that he was actually born Christian Andreas Doppler. But on his graveside his name is presented as Christian Johann Doppler. Depending on sources, he has also been cited as Christian Andreas Doppler and Johann Christian Andreas Doppler. Let's just go with his last name. Interestingly, the Doppler effect was not confirmed by its theorizer. Rather, it was a Dutch scientist named Christoph Hendrik Diederik Buys-Ballot, 1817 to 1890. Who proved it by conducting an experiment in which he was trying to refute Doppler's theory. Buys-Ballot set up a series of trials by a railroad track in Utrecht, the Netherlands. An accomplished horn player rode a train while a second highly trained musician stood by the tracks. Listening to the first musician play a note on the horn. After 2 trials called on weather, a third trial confirmed that Doppler was correct about how sound waves change with motion.
Are there any circumstances where air pollution could be beneficial?
Yes. In fact, dust storms and volcanic ash can be a means for nature to distribute soils across the surface of the planet to regions that might not otherwise get certain nutrients. For instance, the Amazon rainforest may be famous for its verdant plant life. But in actuality the soil beneath the dense canopies is of very poor quality. Dust blown across the ocean from Africa to South America may help fertilize the rainforests. Not only that, but such storms bring nutrients to plankton in the ocean, which form the basis for aquatic food chains.
Is static electricity similar to lightning?
Yes. When you generate a static charge by, for example, wearing wool socks and rubbing your feet on a shag carpet, and then touching a piece of furniture or a person, the spark that is released is just like a miniature bolt of lightning. Static electricity charges can generate 40,000 volts or more, which, as some people know, can be damaging to electronics, such as computers.
Are all funnel clouds tornadoes?
No, in order to be classified as a tornado, the vortex needs to touch both a cloud above and the ground below. If it does not, then it is just considered to be a funnel cloud. Also, not all tornadoes have visible funnel clouds. If there is not dust and debris in the vortex, the tornado may be invisible or nearly invisible to the naked eye. Interestingly, you can have a tornado without a funnel cloud, because a cloud that descends to the ground without rotation can also be categorized as a tornado.
What are the consequences when glaciers melt?
Glaciers that have melted in the Himalayas, home to the world's largest mountains, have filled up and burst the banks of nearby glacial lakes, filling rivers and causing widespread flooding and death to nearby populations downstream. Similar consequences will likely befall those now living near other glaciers around the world.
What are waterspouts?
Often associated with tropical cyclones, waterspouts are tornadoes that can form over a body of water. Instead of sucking up dust and debris, the funnel is visible because of the water it carries. While they tend to be weaker than tornadoes, they can still be lethal and have been known to destroy small boats and cause damage to larger vessels. The most common place to find waterspouts in the United States is off the coast of southern Florida.
What are major and minor ice age periods?
Of course, not all scientists agree on how to divide the periodic ice ages, with some calling for a more strict division between the times and temperatures. For example, some scientists believe a major ice age period should be defined as lasting about 100,000 years. With a 9 degrees Fahrenheit 5 degrees Celsius decrease in temperature between glacial and interglacial periods. A minor ice age period, lasting about 12,000 years with a 5 degrees Fahrenheit 2.8 degrees Celsius decrease in temperature. And a smaller ice age period, lasting about 1,000 years with a 3 degrees Fahrenheit 1.7 degrees Celsius decrease in temperature.
What are nacreous clouds?
Nacreous clouds are clouds that occur at elevations of 12 to 20 miles, 19 to 32 kilometers high, rarely at lower altitudes, and look like cirrus or altocumulus lenticularis clouds. Often quite beautiful, they are sometimes called mother-of-pearl clouds because of irisation. Supercooled water droplets causing refraction of sunlight that gives the edges of these clouds multiple colors in a kind of mother-of-pearl effect. Seen in northern climes, such as Alaska, Scotland, and Scandinavia. These clouds form only a couple hours before sunrise or after sunset.
How is the troposphere defined?
The troposphere is considered as the layer closest to Earth and is also the region where temperatures reliably decrease with altitude. The troposphere is thickest at the Earth's equator, reaching heights of about 11 miles. 17 to 18 kilometers, and this is, therefore, also where you will find the coldest tropospheric temperatures. It might seem rather ironic that, right above the world's steamiest tropical forests, temperatures can be as low as -110 degrees Fahrenheit -79 degrees Celsius.